Hello, this is Nitin Dahad with the Times, and I'm here with Jim McGregor, who's with Tirias Research. Hello, Jim.
Hello, Nitin.
We're here well, what you'd say is the middle of the desert, but it's actually in Arizona and in Chandler, and we've had some a few announcements from Intel this week, haven't we? And
Yes, we have.
everything from doing the Fab tour and seeing Fab 52 and
Yes.
42, and then the announcements of Panther Lake and Clearwater Forest. But what's been the highlight for you, Jim?
Well, I would say the highlight is obviously there's been a number of technology and product announcements here, but the highlights really come down to, I think, four things. One is their 18A process technology.
Yeah.
They finally shifted from this is what we're going to do to we've done it, and
Yeah.
we've got two new products based on it. So, and then there's those two new products. We have Panther Lake for the PC, for thin and light PC, or for the mobile PC. We have Clearwater Forest, which is their efficiency core, next generation efficiency core Xeon product for the server market. And once again, and within those two products, we also have Dartmouth, which is their efficiency core that's going to be a key part of both Panther Lake and Clearwater Forest. So those are kind of the key takeaways for me.
So, I mean, let's break those down. I think, first of all, I mean, my trip started with a Fab tour.
Yes.
And I've been on many Fab tours, and they're all the same. You see the pod, the highway, the pods going around and everything. But it just feels like when you go there, you say, yes, this is real. We were only given 50%. We only saw 50% of each Fab, 42 and 52.
Yes.
52 is a new one using, for 18A, and I think 42 is the existing one. But that 52, they've got one already in Hillsboro, Oregon, and this is a new one here.
Yeah, they have their D1X, which is their development fab in Oregon, and
Yeah.
that's already running on 18A and working on 14A.
Yeah.
And now they have, and this is actually their fifth fab at this facility. It's a 750-acre facility. It's huge.
Yeah.
So they've got 12, 22, 32, 42, which is on 7 nanometer, and 52, which will be on 18A.
And there's 62
14A,
coming.
And 62 just beyond that, where they have pretty much an empty building at
Yeah,
this point.
yeah. But we got to see 42 and 52, and I think obviously the bit we saw of 52, I think, was half still to be done, tooled up and everything. But
Yes.
But what they're telling us is it's been running, and they've been churning out product on 18A since the beginning of this year.
Yeah, they actually said that Panther Lake's in full production at this facility.
Yeah.
You have to remember that it takes months to actually get a single product out the door.
Exactly.
It has to go through thousands of different steps. So a lot of those products started months ago just to start production.
I actually asked the question, so what's the timeline from receiving the wafer to the shipping? But I think that's something that most companies don't want to answer because
No, they don't want to answer.
But it's an interesting, as you say, it takes months
Yeah.
because of all the processes, and you see that. So the fab tours are fab tours, and every fab is like pretty much the same. But I think the process is when you see, and we don't have the chip here, but all of that equipment and 750 acres, and the end product is that tiny thing.
Well, and for me, the biggest thing was just seeing those EUV machines. I mean,
Yes.
these things are huge. They're the size of a small house.
Yeah.
And they already have 4 installed here.
Yeah.
And room for, I think, 6 or 7. So
Yeah.
it's going to be impressive when they have all those installed and up and running. I mean, this is a very, very large facility.
Yeah, and I mean, those EUV machines, even the latest one, which I've seen at IMEC, the ITF, and you walk down and you think, like, when does this ever end? I mean, yeah.
Well, and it's not just the length and width of it.
It's down.
It goes down
Yeah.
2 subfloors.
Yeah. So on my tour, there's a group of mixed sort of knowledge. So, it was just good to hear, reiterate some of the things that goes into a fab and all the
Yes.
gubbins that go underneath, and then the concrete, for the precision, stability, and all that.
Oh yeah, they have to. They were mentioning that just the concrete floor for some of these machines has to be like 4 feet thick.
Yeah. Yeah.
It's incredible.
Yeah, well, there you go. So, I mean, the key takeaway from the Fab tour was that, it's running. They're churning out stuff on 18A.
Yes.
And I think this is a key message Intel wanted to get out, because everybody's been saying, yes, no, whatever. But I think,
Yeah, there's been a lot of rumors about it's behind schedule or whatever. It's not behind schedule. It was already in, and we don't know if they have other existing customers. We know that other customers have tested on the process.
Yeah.
We don't know if they have any confirmed customers at this point in time. However, we do know that they've got 2 products already running on 18A.
Yeah, yeah. Well, I mean, I interviewed Mike Massey for the Edge Computing Group.
Yes.
And I did push him. You'll watch the interview, I think, on this series of interviews here. But I did push him on, what the customers and the products. But he said, they've had, I don't know if he said hundreds of people looking at development. On Panther Lake, so I think they've got sort of software out there. They've got dev kits and things like that. So
absolutely,
So-
and they're looking at Panther Lake not just for the PC, and we should probably explain that this is going to be a family of products, and they're also looking at it, as an edge device for an edge solutions.
Yeah.
Not just the retail, but actually beyond that for robotics, for other types of applications, and they're going to have several different versions that go down to some of the lowest watt range. You're talking sub at least 20 watts, and then all the way up to PC levels where you may be at hundreds of watts.
Exactly. I mean, that will come on my interview with Mike Massey, where we talk about, it's not those edge devices which have the MCU in them. It's basically the bit that processes the data that comes from that, where you've got multiple nodes and multiple sensors. So in automation, industrial automation, manufacturing. They talked about retail as well. The point of sale displays, the interactive displays. But the other big thing. So interactive displays, and you talked about
Robotics.
Robotics, yes.
Oh, I think there's something else to be said about Panther Lake.
Okay, yeah.
I mean, this is several years ago when they were re-architecting their whole roadmap. Panther Lake was kind of a key stake in the ground, saying this is where we're going to be highly competitive with the ARM-based solutions from Apple and from Qualcomm. And we didn't see that comparison, so we're going to have to wait for the benchmarks and actually wait for testing these.
Yeah.
And we're probably not going to have those till Q1 of 2026, but we'll have to see, because, I mean, that is a key mark of how competitive are these products going to be and how competitive is Intel's roadmap.
Yeah, and just to reaffirm, Panther Lake is on 18A, so
Yes.
so I think that's good. Let's go to Clearwater Forest, the Xeon 6 Plus.
I still don't understand the plus.
Why didn't they? Yeah, the presentation they started with Xeon 6, and then they said Xeon 6 Plus, and I thought, hang on.
Why not 7?
Yeah.
It is a new core. It is a new product. It's a new process. Why didn't it qualify for 7?
Yeah.
I don't know. I don't get that. But it is a brand new product. They essentially doubled the number of cores. They doubled everything on this.
Yeah.
They went to a Foveros 3D packaging process. So
Yep.
this is a completely different architected chip. And they used the new Dartmouth efficiency cores. And
Yes.
they essentially doubled pretty much everything, especially the core count.
Yeah.
They went from 144 to 288 cores per chip.
Yeah.
So in the 2-piece system, you have over 500 cores. I mean, this is a significant jump in terms of looking at Sierra Forest, the original Xeon 6 part.
Yeah, I think what impressed me is, again, this is not technology, but how they did the graphics to display all the stacking of all the cores, the tiles, the base tiles, the I/O. I think what we've got is not just the electronics, but we've got the rendering of the graphics to actually deliver how this is all put together. I think Intel have done it well.
I think we're seeing some use of AI here. So,
Yeah.
I mean, that's actually cool. But you're right.
Yeah.
They did a very good graphical job of showing how all these things are architected, how they fit together, and even, kind of pulling it apart so you could actually see different parts of the die and the interconnects and everything else.
And yes.
The interconnects are hard. I mean, you got to think 3D chip. You've got the memory and compute die. Then you've got them connecting on a base die, and then you've got those connecting on a planar level with other I/O dies, and then you have them connecting on another level with the package.
Well, I mean, we've been talking about EMIB for a while, but actually, visually, it's the first time I actually got EMIB today,
Yes.
with that presentation. So, it's actually, the EMIB, the Foveros, and then all the different tiles and everything else. It was pretty impressive.
It is impressive, and it gives you a feel for how complicated these solutions are. It's funny because we used to say that, it's like building a factory on a chip. Now these are like building a city on a chip.
Yeah, and when you see that picture of the whole
Yes.
cross section, it's like a skyscraper.
It is.
And I think it's pretty impressive. But I think go to the technology. I think the thing that's driving this is the gate-all-round technology, as
big
well
time,
as a power
yes.
via I'm not sure how you say it.
Via
but
the backside,
Yeah.
allowing the backside and the backside power.
That's
So
right, yeah.
having the power on the backside of the wafer, having those vias actually through silicon vias, not only going through the wafer, but actually going through the different levels on the wafer, and still having all those interconnects in the different stacks for the logic, the memory, and the I/O.
I remember at DAC 2 years ago, people were asking me, "Oh yeah, so do you really think backside power is going to work?" But I think Intel have shown us that
It is, and it wasn't something that they just added on. It's something that they designed around.
Yes,
and that
exactly.
was kind of a key part of it. So
Yeah.
they really improved the efficiency without without increasing the cost too much.
yeah.
So they really designed for this, and I think that was the most important part.
Now, what do you see the potential for Clearwater Forest now in terms of the whole market?
And they made a transition when they went to having these P cores and E cores. The P cores for the traditional performance workloads, and the E cores really for that throughput. When you really need just that performance going through the chip. So they really designed this for like cloud native workloads, for communications applications.
Yes, the telcos, the 5G telcos.
Exactly.
Yeah.
And that's where I think they did a great job. First off, they got rid of the hyper-threading because you really didn't need that when you're doing this type of processing. I mean, think of it as a network processor on steroids
Yeah.
with just massive amounts of throughput. And that's really what it was designed for. And I think they did a great job with that, And you have to remember that they started this journey a couple generations ago. They had the E-cores on Meteor Lake, and then they made a huge improvement on the E-cores going to Lunar Lake.
Yeah.
And now this is the next generation with
Yeah.
Dartmouth.
Exactly.
And I know and just the fact that they were able to double the number of cores and have architectural improvements on top of it, while increasing even the memory bandwidth by almost 2x.
Yeah.
I mean, that's really. I mean, you're actually. At this point, you're actually looking and saying, okay, I can actually significantly increase my ROI and reduce my footprint by going to this new technology.
Yeah, amazing. We can't do a piece on Intel without commenting on the culture and the philosophy. I think being here these few days in Arizona, you felt the change from the change of direction in the whole executive management.
Yes.
I mean, obviously, Lip-Bu wasn't here, but what we did see is the management team are sort of serious about getting stuff done.
Yes, and you definitely, and that's a big part of this event, was actually just meeting some of the new people in those executive roles. And even the feel of it, it's kind of funny because you had everyone walking around from Intel with these Panther Lake, these really cool Panther Lake shirts on.
Exactly.
We never would have seen that from Intel before.
Exactly.
Everything had to have a chip or just the Intel logo or a wafer on it. These are actually cool. Everyone wants one.
Yeah. Well, you were commenting I want one as well, I think.
I do.
Yeah. But no, I think the new direction, the new leadership, and obviously you've got other things going on with NVIDIA as well. But taking that aside, everybody's on message as well. So I think that was
They
quite
are.
interesting. But people felt maybe a little bit more relieved at the direction it's going in.
I would definitely agree with that. I mean, there's been structural changes to Intel, but I think that the shock and awe of all those changes and all those layoffs and everything has kind of gotten over, and everyone's just back down to work, and they're excited about the products they're coming out with.
Yeah.
So that
There is
kinda
excitement
comes through.
Yeah. Well, Jim, thank you very much.
Thank you, Nitin. And goodbye from Arizona.